Radiology, How It Has Completely Revolutionized the World of Medicine by Bridger Kimber. Radiology has completely revolutionized the world of medicine by changing the way that we diagnose problems in the human body, and it has increased the speed and accuracy of diagnosing these problems, therefore saving more lives. The ideas behind radiology were inspired by the inability to assist or help people who were suffering from unknown medical complications. The medical specialty of radiology permits doctors to look at targeted areas inside of the human body, allowing the medical personnel for the first time the ability to pinpoint the problem and promptly work towards a medical plan to cure the problem. Whereas in the past, it could take weeks to find the root of the problem and come up with a solution, today the ability is present to have the main medical concern pinpointed in a matter of minutes, thus saving countless lives. In 1895, Wilhelm Conrad Röntgen discovered X-rays. On the evening of November 8, 1895, Wilhelm was in his laboratory in Bavaria when he found out that the discharge tube was covered with a thick black carton to exclude all light, then with a paper plate covered on one side with barium and platinocyanide and placed in the path of the rays, it would become fluorescent, even when it was as far as 2 meters from the discharge tube. During many of the tests, he found out that objects of different thicknesses, when interposed in the path of the rays, would show variable transparency to the rays when recorded on a photographic plate. When he had his wife put her hand in the path of the rays, he observed an image of his wife's hand, which showed the shadow thrown by the bones of her hand. Also, the ring that she was wearing, surrounded by the flesh, which was more permeable to the rays, and therefore threw a fainter shadow. This was the first röntgen ever taken. In further experiments, Röntgen showed that the new rays are produced by the impact of cathode rays on an object. In 1896, Antoine Henry Becquerel discovered radioactivity. He learned that X-rays issued from the area of a glass vacuum tube were made fluorescent when struck by a beam of cathode rays. Becquerel also learned that his uranium salts continued ejecting penetrating radiation even when they were not made into phosphorescence by the ultraviolet in the sunlight. Becquerel's rays seemed not especially significant at the time, as the far more popular X-rays could take sharper shadow photographs and faster. It required an extension in 1898 of the radioactivity to another known element, thorium, and the discovery of a new radioactive materials, polonium and radium, by Madame Curie, the physicist who was known for her expertise in chemistry, to awaken the world and Becquerel to the significance of his discovery. In 1913, William D. Coolidge introduced the Coolidge hot cathode tube. The tube operates by the cathode filament emitting electrons as it heats up. The hotter the filament gets, the greater the emission of the electrons. These electrons are accelerated towards the positively charged anode, and when the electrons strike the anode, they change direction and emit X-rays with continuous range of energies. Coolidge's invention revolutionized the generation of X-rays, and its model is upon which all X-ray tubes for medical applications are based. In 1914, Max Theodor Felix von Laue received the Nobel Prize in Physics for X-ray diffraction from crystals. This enabled scientists to study the structure of crystals and hence marked the origin of solid-state physics, an important field in the development of modern electronics. Laue was the first to suggest the use of a crystal to act as the grating for the diffraction of X-rays, showing that if a beam of X-rays passed through a crystal, diffraction would take place and a pattern would be formed on a photographic plate, placed at a right angle to the direction of the rays. In 1934, Frederick and Irene Curie discovered artificial radionucleosides. Unfortunately, the early stage of their careers was defined by failure rather than success. Not only did the married couple fail to discover the neutron, misidentifying it as a gamma ray, they also just missed discovering the proton. Later on, the observation of the particles, they discovered artificial radiation. They noticed that the bombardment of aluminum with alpha particles resulted in the emission of neutrons and protons. What astonished the couple was that the emission of protons continued after the alpha source had been removed from the target. Immediately, Frederick and Irene performed a careful analysis, which showed that the alpha bombardment had produced a proton-emitting radionucleoside. We would not be as advanced as a society as we are now if radiology hadn't been discovered. Radiology, also known for many other applications in the world, has enabled doctors to make a much better diagnosis because they have a window to look inside the human body.
So I've been asked what radiology has done for the world in general, and I would say that its primary impact has been on the field of medicine. I think the fact that diseases can be diagnosed so much more quickly and so much more accurately than without radiology has had a tremendous impact to save countless lives. But it's not just medicine. I think science in general. In fact, I have a book here on Rosalind Franklin, and she was the woman who did the X-ray crystallography of the structure of DNA when they were trying to figure out the double helix structure of DNA. And she did X-ray images of the DNA molecules, which helped Watson and Crick figure out that it was a double helix, which has done tremendous things for the field of genetics. Radiology is used in industry. Aircraft parts are X-rayed to see if there's micro flaws in engines. So think of what the aircraft industry or just industry in general would be like without the ability to have X-rays to look inside of machines and look to see if parts are meeting specs, and if there's any danger to air travel. It's also used in fighting terrorism. We have X-ray machines at our ports that look through cargo containers to see if there's any kind of explosives or dangerous materials inside of cargo containers. So it's really pervasive throughout our life. It's used in science and cosmology. There's X-ray observatories that look out into the universe and look at X-rays instead of visible light to look at the universe. So it's had really a broad application throughout the fields of science and technology, and not just medicine, but I think in medicine in particular, it's had giant impacts and really changed the whole course of the medical field and a lot of our other sciences.
A patient might say that something is hurting on the left side of their body, but the X-ray might show that it is something on the right side of their body causing the left side to hurt. This is called alternative diagnostics. Diagnostically, radiology permits the doctor to look inside the body and pinpoint the problem, therefore increasing the accuracy and speed and potentially identifying greater health issues for the patient. Radiology also provides a visual image the doctor can use as he informs the patient of their medical concern. Radiology is one of the medical specialties that responds to technology.
One of the great things about radiology as a field in medicine is that it's very technologically related. When I started in the radiology practice 25 years ago, CAT scan was just beginning, and part of that was because computers were much less powerful than they are now. It would take 45 minutes to do a CAT scan of the head, and today we can do a CAT scan from the top of the head down to the bottom of the pelvis in 1 minute to 2 minutes, with resolution down to a millimeter.
In closing, you can see how radiology has allowed a major turning point in history, not only through the efficiency and effectiveness that it brings to the world of medicine, but to the world in general, completely revolutionizing the world of medicine and so much more.